The objective of this lesson is to identify the volume of a rectangular prism by packing and counting cubic units. Let's begin by looking first at an image representing the area of a two-dimensional rectangle. To determine area, we could count the number of squares in the colored section, or we could use multiplication. In this example, the area is 5 times 9, which is equal to 45 square units. Next, let's look at a three-dimensional rectangular prism. While the previous image was flat, only including length and width, this rectangular prism has height, width, and depth, and each of the prism's 6 faces is a rectangle. The space the entire prism occupies is called volume. Volume can be measured in 2 ways. First, by filling a container. This method uses liquid measurements such as fluid ounces, pints, liters, and so forth. The second method to measure volume is to pack a container the way one might pack a shipping container with boxes. The volume of the container could be stated by the number of boxes it takes to fill it without any gaps, empty spaces, or any overlaps. We will use cubes, such as this one, to begin measuring volume using the packing method. These cubes are called cubic units. We use cubes rather than other solid shapes because cubes fit nicely together regardless of which face of the cube we line up. Let's look at 3 examples of shapes we can create with our cubic units in order to determine their volumes. To measure volume, we will recreate these shapes using our cubes and then count the number of cubes required to construct each shape. The first shape looks like this. It is 2 cubes long, 2 cubes wide, and 3 cubes high. After counting the cubes, we can determine the volume of this first shape is 12 cubic units. For some, it may be necessary to create each layer of the rectangular prism one at a time in order to understand volume. As we add each layer separately, we can gain increased experience with the third measurement of height for three-dimensional objects. The second shape is 4 cubes long, 3 cubes wide, and 2 cubes high. Again, by counting the cubes, we can discover the volume to be 24 cubic units. The third shape is more difficult. Part of it looks like the first shape, but it includes an extra section that is 2 cubes long, 1 cube wide, and 3 cubes high. We can recreate it using our cubes and then count to find the volume to be 18 cubic units. In each of these examples, we used the packing method to determine volume, with each cube placed as if it were a box packed into a container. The objective for this lesson was to identify the volume of rectangular prisms by packing and counting cubic units. We met this objective by looking at the similarities and differences between the attributes of area and volume. We also used the packing method to create rectangular prisms so we could count cubic units to determine volume.